Writing better code on Electron and Node. A close look on the Electron Render New API. Render process. So as we all know, Electron is pretty much composed of two main processes. The main process, which has relation with the operating system and the kernel and everything underneath that. And of course, the render process, which is what users can actually see and interact with as a graphical user interface, or pretty much a GUI. So any two processes or more running on a machine needs a protocol to communicate, and Electron pretty much uses the IPC. So for some of you, if they ask like why Electron chooses the IPC over any other protocol specifically, I pretty much say simply because the IPC is the most simplest and reliable protocol that can be implemented inside of the Electron's core framework. So multiple render or inside render processes. So Electron relies on Chromium for rendering web pages. Therefore, Chromium actually runs every single web page, or pretty much you can tell it every single Electron window, on a completely separate process. Why is that? There's actually a couple of things actually, but every single window which gets dispatched from the main process to render some specific web page or a URL from a server or web view or anything like that, it actually gets its own process registered on the operating system. It's simply because it allows easier management for each process to shut down or start for a new window, for a new web page. Whenever you try to render a new web page on a separate window or a separate web view, creating a process or manipulating it is much easier than putting everything on a single process and trying to manipulate all the tasks underneath the specific process. It also allows your applications to tolerate faults and gets more reliable, since when a window crashes, it doesn't bring the whole application down. And that's pretty great because fault tolerating or tolerated to faults is actually a generic term where it comes actually to handle exceptions specifically whenever a crash happens on a specific web page or a specific Electron window. It doesn't bring the whole application down and everything gets back to work fine. Only the crashed part is going to get handled specifically. When it comes to security, it plays a major role when comes to Electron. So it isolates each web page window on its process to prevent data forgery. And data forgery is actually a term representing a process can actually steal from other processes, or pretty much when you're running a window, when it runs on the same process, data can actually be manipulated between multiple pages. So like when you're running a window or another web page can access other web pages and view its content or alterate the actual data that the user can see and can interact with. And this can be really dangerous when it comes to rendering web pages and web forms, when it comes to payments and so on and so forth. So each one of them has its own process. Is actually a great deal to start with. Render Electron or Render Electron modules. So for Electron modules, there's actually a couple of them, or like two types of them. One that you can actually include inside of the main process. The other one is actually you can include inside of the render process. And there are shared ones between both of the processes that can be easily required and used without any issues. So from the main process, there's a couple of them, like the application, which handles the main application instance of your Electron's running application, plus the auto updater, the IPC main, the menu items, and so on and so forth. For the render process, there's actually the desktop capture. There isn't that much like the IPC render, which pretty much allows you to access data from the main process into the render process on real time. So the IPC render can easily allow from the render process to require other modules that are only available inside the main process. And this is the main point of using the IPC render, or pretty much the remote module, which allows you to do that specifically much more easier. It also allows you to use the DOM and the browser APIs like you were dealing with a normal web page. So that's the main differences between a render process and the main process, and when they actually can share The clipboard, crash reporter, and native image or shell and screen can be required normally on the render or either the main process and used specifically without any issues. The remote module. So the remote modules actually allows you to use main process only modules and objects from the render process without blocking the UI using the IPC protocol. And there, when it comes to the IPC protocol, real work and when it comes to handy. So you can easily verify memory leaks between render and main process of the remotely required module. Of course, you can also remote callbacks are also referenced until you explicitly free them. So there's actually like two or couple of dangers of using the remote module. Most of the people or most of the developers who tries to use the remote module and tries to remotely access some of the modules available in the main process throughout the render process actually finds a lot of issues inside of that. So the main points of using this, or just like a couple of issues, you can learn more about them in the official documentation and how you can prevent of these kind of things from happening, especially like memory leaks. So when you try to render something remotely, require it from the main process, it can be leaks if you don't pay enough attention. On the other hand, when you're passing callbacks from the remote module from the render process to the main process and without you explicitly free them, like since they are events images instances, so you can just remove the callback from the instances or from the callbacks stock so it gets freed, or pretty much it can happen but not most of the time, and it's not reliable. It can be garbage collected. Here's an example of how dangerous code. It looks pretty much innocent, but it is super dangerous to deal with. So here we are requiring the Electron and we are using the remote module inside of it. Then we're just doing the current window. We're getting the current running focused window instance. Then we just pretty much, since it is an instance of the event imager class, we can listen for a specific event and we can emit events too. So we put the close here, we're listening for the close event, and we are running an anonymous callback and this kind of things. Here you can do a code that gets executed once this current window gets exit. And of course, you just close the callback and that's it. Now, in this case, it looks pretty innocent. There's nothing wrong with this code and it runs specifically fine. But once you refresh a window every single time, this callback gets registered.